Blizzard 2016 Polarimetric radar. Well, might as well give it a little fanfare. This polarimetric stuff is pretty cool, but we're looking at the Dover radar here. We've got, this is midnight on Central Time. On the night of 22nd to 23rd, January 2016, we got the blizzard, well, snowstorm coming up from the south. Getting some snow and mixed phase precip across Delaware and Maryland and Virginia. What we have to do, though, we need to start with a surface chart and really see what's going on. This is a prerequisite to really working with radar because ASOS is a little bit better at verifying the precip types. It's not perfect, but that's a good starting point. Plus, we can see the meteorological setup. So surface low is right down in this area. Looks like it's starting to come out of North Carolina towards the Roanoke area, or not the Roanoke, the Norfolk area. Warm front like that, cold front like that. System is tracking northeastward. Overrun areas, of course, north of the warm front. So we're seeing a whole lot of precip here combining with the upper level lift. Freeze line, where's that freeze line? Well, we'll draw out the 32. We just draw that basically from south of Roanoke through southern Delaware and out towards south of Atlantic City. So that's the 32 line. South of the 32 line, we could see sleet, possibly some snow, but certainly rain at some point when you get south of that line. North of the 32 line, we can also get sleet. We can also get freezing rain if stuff is coming down liquid. And, of course, at some point we'll see snow when we have a colder column. And that's certainly the case when we get back in these 21, 23-degree readings, 19. That's probably a very cold column. So this is all snow. And there's the symbol, drawing this with my mouse. Where's the rain? I'm going to draw that in green. Looking at the rain symbols here reported by ASOS, I really miss the days when we had human observers looking at this stuff because we had it spot on what the precip type was. The ASOS sensors have gotten better, but they're not perfect. So there's still errors from time to time. There's the symbol for rain. Anything in between is probably some sort of mixed phase. Could be snow mixed with freezing rain, could be sleet. This is where polarimetric radar really comes in handy. So now the radar site we're going to look at is going to be Dover. We're going to pick that because it's kind of like right on the transition line. That'll give us some stuff to look at. So I'm going to go over to GR level 3. Did that come up? Nope. There we go. So we're starting out with the reflectivity. This is the base reflectivity. There's the scale off to the left, and this is in decibels of power. So pretty much everything is looking 30 to 40. This is kind of like just a pesky continuous precip. We don't know if it's rain or snow at first glance. A lot of times you'll see texturing that kind of gives you an idea what it is. Like a lot of times you'll see a very striated, smooth appearance where the snow is, and where the rain is, you'll see kind of a more cellular appearance with stronger echoes. We don't see that so much tonight. So the polarimetric information is going to really come in handy. So what do we got? Well, let's look at the composite reflectivity. Look at that. There's some stronger echoes right there. Is that thunderstorms? Well, most likely this is ice. The best scatterers of our radar energy are going to be any kind of ice particles, spherical ice, or coated ice with water on the outside. Basically, sleet, coated sleet, that's going to be a very strong reflector, and that's probably what we got here west of the radar site. It's picking that up at some level, not at the lowest levels of the radar at 0.5, but if we go higher, maybe 1.8. I don't think we have that product available. 2.5. Yeah, we're starting to pick it up right there. 3.5. Now it's even stronger. So this is up at the bottom panel shows this is 5,000 feet. That's where that is. So there's probably some snow that's melting on the way down, possibly. And the other thing that we see is a bright band. You see that ring around the radar? The radar beam points slightly upward. This is the 3.5 degree slice. And it hits this range at a height of about 6,000 feet. So we know that the melting level is around 6,000. And below that, some warm air, probably from the stuff streaming northward at 850. And then even further down, we start picking up the cold air at the surface. So kind of like 3 air mass layers involved here. Well, it could probably just be 2. I'd have to show you the sounding. But in any case, we're looking at basically cold over warm with cold underneath. So kind of complicated right there. Okay, I figured it'd be good to start with the hydrometeorological classification algorithm rather than get into the ZDRs and everything first. So what is this showing us? This is the Dover radar. It's indicating this area of green here. We go over to the side here and that shows that that's rain. Or we can set the cursor over it and read that off down in that box right there. See that? Actually, I need to move this up a little bit. There we go. So you can see it's reading RA down there. But if we get further away, it's DS. So why is that? Why are we surrounded with DS, but we got rain in the middle? Well, we have to remember that the radar beam is extending upward. It travels upwards as it gets further away from the radar. So when you get to this range away from the radar, you're not only about 40 or 50 miles away, but you're also about 6,000 feet in the air. And beyond that, when you get onto this area, you're beyond 60 miles and above 6,000 feet. You're probably up at 10 or 20,000 feet. So yeah, up at those levels, it's cold and you're going to get DS, which is dry snow. So this is indicative of warmish temperatures at the surface, like near freezing, maybe a little bit above freezing, and very cool conditions in the mid-levels. But there's a couple of odd areas. See this purple? There's GR. So it's picking up kind of a mixed phase going on here, and also a mixed phase here. So this is unusual because we don't have that going on to the north. We don't really have it going on to the east. This is probably telling us that we've got probably a little bit of a push of warm air advection coming through here, shaking things up in the mid-levels like 6,000 to 12,000 feet, and causing a little bit of a conversion over to mixed phase precip. So that's probably the warm air advection coming in. It's helpful to look at some other radars. Let's go down to this one here near Norfolk. Same picture showing rain near the surface, dry snow aloft, but there's that mixed phase stuff. And there's some blue blotches in there that says it's wet snow. So that would be snow falling down and melting as it comes down. Then there's this area of gray back here. It's biological. It's probably not able to classify whatever's going on out here. And then one other area we'll look at is the Dulles radar. So we're going further north, and you can see it's overwhelmingly dry snow even at the surface. But you go to the southwest, there's that mixed phase stuff there. So the radars are screaming at us that there's some pretty good warm air advection set up along the Patuxent River. Is that right? I can't remember the Potomac River. I'm thinking of Patuxent Naval Air Station. So yeah, there's warm air advection coming up, and that's definitely going to be associated with some low-level lift that's probably intensifying things a bit. Other stuff to look at would be ZDR. ZDR is a differential reflectivity. That's a measure of the shape of the particles that the radar is picking up. So if we're talking about rain falling down kind of mashes up against the air as it falls, and it produces this oblate shape that looks like that. So if we take a look at the radar energy in the horizontal, we return a whole lot more in the horizontal plane than we do in the vertical plane. And that comes back as high. I'm going to put H for high. So we're talking about values of 2, 3. If it's spherical, it's going to return equal horizontal and vertical energy, and that's going to give us a ZDR of about 1. Anything below that is indicative of a prolate shape, kind of like that. So that would be melting stuff, hail, wet hail, sleet, melting snow, that kind of thing. And that's going to give us values of 0 to 1. So what is this showing? Well, here at Dulles, the values are in this range. They're from about 0 to 1. So this is probably like icy type stuff. But if we go further east to Dover, the ZDRs change a little bit. We pick up some higher values. See right there? This is probably some rain or some, yeah, probably rain being picked up by the radar. And if we go all the way down to Norfolk, assuming I can click on this, I'm having fighting with the cursor here. There we go. Okay, pulling up the Norfolk ZDR, you can see it's even a lot higher there. So it's picking up more of a rainy type pattern. That's probably associated with a lot of persistent warm air direction riding up over that. But remember, when we get a certain range from the radar, like 40, 50, 60 miles, we're getting in higher levels, and we're going to expect to see those ZDRs diminish. KDP, we don't need to worry about that. That's better for thunderstorms. I'm not going to worry about that too much, but correlation coefficient, this is the diversity of shapes. That's probably a good way to put that. So if we're seeing a whole lot of mixed phase precip, it's going to show up kind of yellowish, like what we see right here. If it's uniform, like with dry snow, it's going to show up kind of as a purple shape. So purple, you can see that has a ZDR close to 100. I got to move the scale down to show you that. See that? So it's up to 100. Anything like 92 to 97, that's going to be in the mixed phase. Anything below that is going to be either hail or nothing. That's probably the reason it's picking up this area here. It doesn't know what to do with that. This is not really natural, and I don't know what that is. It's probably just maybe, see, base reflect. Yeah, there's nothing there. So maybe it is biological. Maybe it's picking up some dust or birds. Maybe birds. I wonder if some birds got swept into the circulation. That's definitely a possibility, considering the long fetch of warm air. Anyway, let's see. We're done with the correlation coefficient. I'm going to probably maybe pan that up a little bit north to Dover. So yeah, picking up mixed phase stuff just south of Dover and south of Baltimore. So if you're in those areas and you see that moving north, that probably clues you in that you're going to get kind of a switch over to maybe some sleet or possibly freezing rain, that kind of thing. And let's see, this is just kind of a very basic introductory thing. Don't want this to run on too long, but that kind of gives you the essentials, especially with this storm system coming up from North Carolina. I put that on Norfolk, and there it is, moving northward. So anyway, that's just kind of a quick primer there, and I hope you enjoy that, and we'll see if we can do some videos tomorrow if anything's going on. Thanks.